All right, this will be Pilot's Handbook of Aeronautical Knowledge 2-6, the landing gear. Ooh. The landing gear is a principal support of the airplane when parked, taxi, taking off, or landing. The most common type of landing gear consists of wheels, but airplanes can also be equipped with floats for water operations or skis for landing on snow. The landing gear consists of 3 wheels, 2 main wheels, and a third wheel positioned either at the front or rear of the airplane. Landing gear with a rear-mounted wheel is called a conventional. Landing gear with a rear-mounted wheel is called conventional landing gear. Airplanes with conventional landing gears are sometimes referred to as tail wheel airplanes. When the third wheel is located on the nose, it is called a nose wheel, and the design is referred to a tricycle gear. A steerable nose wheel or tail wheel permits the airplane to be controlled throughout all operations while on the ground. Most aircraft are steered by moving the rudder pedals, whether nose wheel or tail wheel. Additionally, some aircraft are steered by differential braking. Okay. So now we're going to go into the power plant on 2-6. The power plant usually includes both the engine and the propeller. The primary function of the engine is to provide the power to turn the propeller. It also generates electrical power, provides a vacuum source for some flight instruments, and in most single-engine airplanes provides a source of heat for the pilot and passengers. The engine is covered by a cowling or a nacelle, which are both types of covered housings. The purpose of the cowling is to streamline the flow of air around the engine and to help cool the engine by ducting air around the cylinders. The propeller mounted on the front of the engine translates the rotating forces of the engine into thrust, a forward-acting force that helps move the airplane through the air. The propeller may also be mounted on the rear of the engine, as in the pusher-type aircraft. A propeller is a rotating airfoil that produces thrust through aerodynamic action. A low-pressure area is formed at the back of the propeller's airfoil, and a high pressure is produced at the face of a propeller, similar to the way lift is generated by an airfoil used as a lifting surface or a wing. The pressure differential pulls air through the propeller, which in turn pulls the airplane forward. There are 2 significant factors involved in the design of a propeller which impacts its effectiveness. The angle of a propeller blade, as measured against the hub of the propeller, keeps the angle of attack relatively constant along the span of the propeller blade, reducing or eliminating the possibility of a stall. The pitch is defined as the distance a propeller would travel in one revolution if it were turning in a solid. These 2 factors combine to allow a measurement of the propeller's efficiency. Propellers are usually matched to a specific aircraft power plant combination to achieve the best efficiency at a particular power setting, and they pull or push depending on how the engine is mounted. Subcomponents. The subcomponents of an airplane include the airframe, electrical systems, flight controls, and brakes. The airframe is the basic structure of an aircraft and is designed to withstand all aerodynamic forces, as well as the stresses imposed by weight of the fuel, crew, and payload. The primary function of aircraft electrical system is to generate, regulate, and distribute electrical power throughout the aircraft. There are several different power sources on aircraft to power the aircraft electrical systems. These power sources include engine-driven alternating current, AC, generators, auxiliary power units, APUs, and external power. The aircraft's electrical power system is used to operate flight instruments, essential systems such as anti-icing, etc., and passenger services such as cabin lighting. The flight controls are the devices and systems which govern the attitude of an aircraft and, as a result, the flight path followed by the aircraft. In the case of many conventional airplanes, the primary flight controls utilize hinged, trailing edge surfaces called elevators for pitch, ailerons for roll, and rudder for yaw. These surfaces are operated by the pilot in the flight deck or by an automatic pilot. Airplanes' brake consist of multiple pads, called caliper pads, that are hydraulically squeezed toward each other with a rotating disc called a rotor between them. The pads place pressure on the rotor, which is turning with the wheels. As a result of the increased friction of the rotor, the wheels inherently slow down and stop turning. The disc and brake pads are made either from steel, like those in a car, or from a carbon material that weighs less and can absorb more energy. Because airplanes' brakes are used principally during landings and must absorb an enormous amount of energy, their life is measured in landings rather than miles. Alright, we'll hold off there on page 2-7. That was going through the landing gear, the power plants, subcomponents. Alright.